There is a question so simple that a child could ask it, and so treacherous that the more carefully you think about it, the less certain you become that it means anything at all. The question is this: what existed before the beginning of time? Not before the Earth, not before the sun, or the first galaxy, or the first atom. Before all of it. Before the moment physics calls the beginning. You have probably asked some version of this question yourself, late at night. Half joking, half not. What was there before the Big Bang? And you have probably received, at some point, an answer that sounded confident, but left you strangely unsatisfied. Something like, there was nothing before the Big Bang, because time itself began there. And on the surface, this sounds like an answer. It has the shape of an answer. But sit with it a little longer, and it starts to dissolve. Because here is the problem hiding inside that sentence. To say something began, you need a moment before it began, and a moment after. You need a timeline. You need a before and an after separated by an event. But if time itself is the thing that began, then there is no before in which nothing existed. Because before is a temporal word, and the thing we are trying to describe is the possible absence of time altogether. It is like trying to describe the silence before sound existed. Except that silence itself is something that happens in time. This is not a linguistic trick. This is one of the strangest and most genuine problems in modern physics. Consider something ordinary first, a wave in the ocean. You can point to the moment before the wave rose and the moment after it broke against the shore. The water existed before, during, and after. The wave was a temporary shape in something that was already there. Every event you have ever witnessed in your life works this way. Something exists, then it changes, then it exists differently. Birth, growth, decay, all of it borrows from a timeline that was already running. Your intuition about beginnings has been trained entirely on events that happen inside time. The Big Bang may not be an event that happened inside time. It may be the edge of time itself, and your intuition was never built to look at an edge like that. Think about a candle being lit in a dark room. Before the flame exists, there is still a room, still air, still a wick waiting in the dark. The lighting of the candle is an event that occurs inside a setting that was already fully formed. This is the model your mind reaches for automatically. Whether you are thinking about a candle, a birth, a car engine starting, or a star igniting, something changes state within a container that was already there to receive it. And this model has served you so reliably for your entire life that you have never had a reason to question whether it applies universally. It does not. The room, the air, the wick, all of it corresponds to space and time themselves in this analogy. And space and time are exactly the things in question at the beginning of the universe. There was no room waiting in the dark. The room itself may be what came into being. This single substitution, replacing an event that happens inside a setting with an event that may be identical to the setting coming into being, is the hinge on which this entire episode turns. Keep it in mind, because we will return to it from several different angles. And each time we do, it'll look a little stranger than the time before. If you are new here, welcome, and get comfortable. Because today we are going to follow this question as far as it will take us. Past the point where most explanations stop, into the place where physics itself becomes uncertain about what it is even allowed to ask. Let us start with what you can actually imagine, because that will tell us exactly where the problem begins. Picture rewinding the universe. galaxies pull back together, stars unravel into gas, gas compresses into denser and denser clouds, until everything you can see, all the matter, all the light, all the structure of the cosmos, is compressed into a single, impossibly hot, impossibly dense point. This is the closest thing to a mental image most people have of the beginning. A tiny fireball exploding outward into empty space. It is a vivid picture. It is also, in an important sense, wrong. The Big Bang was not an explosion happening at a location inside a pre-existing empty space. There was no empty room waiting for it. Space itself was part of what began. This is the detail that quietly breaks the intuitive picture. When we say the universe expanded from a hot, dense state, we do not mean that matter flew outward into surrounding nothingness, the way debris flies outward from a bomb. We mean that the distance between all points of space itself began to increase. Space was not the container for the event. Space was part of the event. This is the part that almost nobody fully absorbs the first time they hear it. The Big Bang did not happen somewhere. It happened everywhere. Because everywhere is exactly what did not yet exist as a separated, extended thing before it. Try to picture that for a moment, and notice how your mind resists it. We're built to think in terms of objects appearing inside space. We are not built to think about space itself being one of the things that appeared. But this is still just the surface of the problem. Even if we accept that space began, we still have to ask about time. And that is where things become genuinely strange. To understand why time is so difficult here, we have to talk about what time actually is in modern physics, not what it feels like to you personally. In Einstein's general relativity, time is not a universal ticking clock sitting outside the universe, counting moments as they pass. Time is a dimension woven together with space into a single structure called space-time. It can stretch, compress, and curve depending on gravity and motion. A clock near a massive object ticks slower than a clock far away from it. This has been measured directly, repeatedly, with extraordinary precision, using atomic clocks flown on airplanes, satellites orbiting the Earth, and instruments sensitive enough to detect the tiny difference in the passage of time between a clock sitting on a table and one sitting on a shelf slightly higher off the ground. Time is not the stage on which physics happens. Time is one of the actors. This single shift from time as a backdrop to time as a participant is one of the most consequential ideas in the history of physics, and it is worth pausing on because everything that follows depends on taking it seriously rather than treating it as a clever turn of phrase. If time can stretch and bend depending on gravity and velocity, then it cannot be the fixed, universal container we instinctively imagine. It behaves more like a fabric than a clock. And fabrics, unlike clocks, can be created, torn, folded, or in principle, brought into existence where none previously existed. Now push this idea to its limit. If time is a feature of space-time, and space-time itself began at the Big Bang, then time began along with it. Not time starting to run at some earlier moment, but time itself coming into being as a structure. This is what physicists mean by the phrase, time began at the Big Bang. It is not a poetic flourish. It follows directly from treating time as a dynamical part of the universe, rather than an eternal backdrop the universe happens to sit inside. And here is where the paradox becomes unavoidable. Asking what happened before the Big Bang assumes a timeline that extends earlier than the beginning of the timeline itself. It's a bit like standing at the northernmost point on Earth and asking, what is north of that? The question sounds grammatically valid. Every word in it is correct. Someone unfamiliar with geography could ask it in perfectly good faith, expecting a sensible answer, a place name, a direction, a distance. But at the North Pole, north as a direction has completely run out. Every direction from that point is south. The concept has not been hidden or forbidden, it has simply exhausted the geometry that gave it meaning in the first place. Before may work the same way. It might not be that the answer is hidden from us, it might be that the question, as we are used to asking it, stops making sense at exactly the point we are asking about. But this is still not the end of the story, and here is the part that quietly changes everything. Part 3. Because saying the question does not make sense within classical general relativity is not the same as saying the question is permanently unanswerable. General relativity is an extraordinarily successful theory, tested to remarkable precision across everything from the orbit of Mercury to the bending of starlight around the sun to the detection of gravitational waves rippling across the cosmos. But it breaks down completely at the extreme densities present at the very beginning. At those scales, gravity is not the only force that matters. Quantum mechanics becomes essential too, and the two frameworks, general relativity and quantum mechanics, do not currently combine into a single consistent theory. Each works magnificently within its own domain, the very large and the very small. But at the point where both domains overlap, at the birth of the universe, our best equations simply stop producing sensible answers. We do not yet have a complete, tested theory that unifies gravity with quantum physics. This missing theory is often called quantum gravity, and the true nature of the earliest moments of the universe depends entirely on what that theory turns out to be. This is the layer where the story stops being settled fact and starts becoming genuine, active scientific frontier. And it is important to be honest about that distinction, because there are real ideas here, studied by serious physicists, published in respected journals, tested against every available piece of observational evidence, that are not yet confirmed, and may never be confirmed in the way we confirm ordinary physical claims, because the direct evidence we would need may be permanently out of reach, hidden behind the very boundary we are trying to understand. One family of ideas suggests that the universe did not begin from nothing at all, but instead emerged from the collapse of a previous universe, a kind of cosmic bounce, where a prior contracting phase reached a maximum density and then rebounded into expansion. Picture an ocean tide pulling inward toward a single point of maximum compression, only to reverse and surge back outward again. Not because something new was created, but because the same water, the same underlying substance, simply changed direction. In these models, time did not begin at the Big Bang. Time simply changed direction there, like a ball reaching the bottom of a valley and rolling back up the other side. Some versions of this idea propose an endless cycle, universe after universe, contracting and rebounding across what might be an unbounded, perhaps infinite sequence of prior cosmic histories, each one largely wiping away the detailed structure of the one before it. If something like this is correct, then the phrase "before the Big Bang" would refer to an earlier contracting phase of an existing universe, not to a timeless void. And the question you asked as a child would have a genuine, if currently unverifiable, answer. Another family of ideas comes from something called eternal inflation. According to this framework, the extremely rapid expansion in the universe's earliest fraction of a second, called cosmic inflation, may never fully stop everywhere. The mathematics describing this expansion suggests that inflation, once started, tends to keep going in most places, even as it randomly stops in scattered pockets throughout the inflating field. Instead, inflation could continue eternally in most regions, while individual pockets our observable universe among them, break off and stop inflating, forming what some physicists describe as bubble universes, each one expanding and cooling into its own vast cosmos, potentially governed by its own local physical constants. If this picture is correct, our Big Bang was not the beginning of everything. It was a local event. The moment our particular bubble stopped inflating and began behaving the way we observe today. Time, in the largest sense, may never have had a beginning at all. Our beginning may simply be one bubble popping into its own history within something vastly larger and older, a process that mathematically appears to have no natural stopping point in either direction, past or future. A third approach comes from quantum cosmology, where researchers attempt to describe the origin of the universe using the mathematics of quantum mechanics applied to the entire cosmos. Some versions of these models suggest that time, as we understand it, may emerge from something more fundamental, something that does not itself have a before or after in any ordinary sense, the way temperature emerges from the motion of countless particles, even though no single particle has a temperature of its own. A single molecule of gas is neither hot nor cold. Temperature only becomes meaningful once you have enough molecules colliding statistically for an average behavior to emerge. Some physicists suspect time might work the same way. A large-scale, statistical, emergent property of something deeper and stranger, perhaps a web of quantum relationships that do not individually possess anything resembling a before or after. In this view, asking what came before time is a bit like asking what the temperature was before there were particles to have a temperature. The question may be built from a concept that only makes sense after a certain threshold has already been crossed, and pushing it further back may not reveal a hidden void, but rather reveal that the concept has simply run out of the conditions it needs in order to apply at all. None of these are proven. All of them are mathematically serious, and all of them lead to profoundly different answers to the question we started with. This is the honest state of modern cosmology. We are not choosing between one confirmed answer and a fantasy. We are choosing between several rigorous frameworks, each consistent with what we currently observe, each suggesting a radically different fate for the question of what, if anything, came before. But this is still not where the story gets strangest, because even if we set aside the question of before, there is something else hiding in the structure of time itself that reshapes the entire problem. Part 4. That something has to do with a concept called entropy. Entropy is often described loosely as disorder, but a more precise way to think about it is this. Entropy measures the number of ways the microscopic details of a system could be rearranged while still looking the same from the outside. A tidy room has very few arrangements of objects that still count as tidy. A messy room has enormous numbers of arrangements that all look equally messy. This is why rooms tend to become messier over time and almost never spontaneously become tidier. There are simply far more messy arrangements than tidy ones, and left alone, systems tend to drift toward whichever arrangement is statistically more likely. Imagine a deck of cards, shuffled into a specific, meaningless order. There is exactly one arrangement that puts every card back in perfect suit and sequence. And there are billions upon billions of arrangements that look like ordinary disorder. If you shuffle the deck further, you will essentially never stumble back into the perfectly ordered sequence by chance. Not because it is forbidden, but because it is staggeringly improbable compared to the near infinite number of disordered alternatives. This is not a special rule about cards. It is a statistical certainty that applies to any system with enough moving parts, from a shuffled deck to the molecules of air in a room to the matter and energy filling the entire cosmos. The second law of thermodynamics takes the simple statistical fact and elevates it into one of the most fundamental principles in all of physics. It states that the total entropy of an isolated system tends to increase over time, moving from order toward disorder, from the improbable toward the probable, and essentially never spontaneously reversing at any large scale. This single principle is one of the deepest reasons we experience time as flowing in one direction at all.
Glass shatters and does not reassemble. Coffee cools and does not spontaneously reheat. Your memories point toward the past and never the future. Nearly every intuition you have about time having a direction traces back to this one statistical tendency toward increasing disorder. And it is considered one of the most reliable laws in all of physics, holding true in every laboratory test ever performed. Here is where it becomes deeply strange. For entropy to increase from the Big Bang onward, the universe must have begun in an extraordinarily low entropy state, an incredibly ordered, improbable configuration, roughly comparable to a shuffled deck of cards somehow starting in perfect sequence, except at a scale involving every particle in the observable universe simultaneously. This is genuinely puzzling because low entropy states are, by definition, rare and statistically unlikely. Why would the universe begin in one of the least probable configurations available to it? This is sometimes called the past hypothesis, and it remains one of the most significant open problems in theoretical physics. We are not simply asking why the universe began, we are asking why it began in a state so specific, so ordered, that its entire subsequent history of increasing disorder became possible in the first place.
It is important to be clear that this is not a settled matter. Various proposals exist, some involving the special dynamics of cosmic inflation, others involving deeper symmetries in the structure of quantum gravity, but none of them has become the accepted consensus answer. This remains, honestly and openly, an unresolved frontier of physics. And this connects directly back to our original question, because the very sense that time has a direction, forward from a special beginning toward growing disorder, might be a consequence of this initial low entropy state, rather than a fundamental feature of reality itself. Some theorists have explored a more radical possibility, still firmly in the realm of speculation, that in a sufficiently large structure, the arrow of time need not point the same way everywhere, and that what we call the past could, in some distant region, be another observer's future.
This is not established physics. It is a serious idea being taken seriously, no more and no less. But if anything like it were true, then asking which direction is really before would not even have a single answer. Before could become a relative concept, dependent on which region of a much larger reality you happen to be standing in. This is the part that almost nobody expects. We assume before and after are absolute, universal directions built into the fabric of reality. But if the arrow of time itself emerges from a special initial condition, rather than existing as a fundamental law, then the entire concept of before may only be meaningful locally, within our particular pocket of whatever the larger structure of reality turns out to be.
Part 5. Let us step back and be honest about where this leaves us, because this is not a case where science has failed. This is a case where science has done exactly what it is supposed to do. It has taken an intuitive question, followed it downward through layer after layer, and revealed that the question itself was built from assumptions that stop applying at the extremes we are examining.
This is not a dead end. This is one of the most productive kinds of discovery in physics. The discovery that a familiar concept, before, does not survive contact with the most extreme conditions we can imagine. The intuition would say something must have caused the beginning, because everything you have ever seen has a cause that came earlier. This is perhaps the deepest intuition break in the entire story, so it is worth sitting with directly. Causality, the relationship between causes and effects, feels like an absolute law woven into reality itself.
But causality, as we use it, is fundamentally a temporal relationship. A cause happens, then an effect follows. Remove time, or reach the boundary where time itself may be emerging rather than already existing, and the entire scaffolding that causality depends on is no longer guaranteed to be there. The error is not in your logic. The error is in assuming that a concept built entirely from ordinary experience, cause before effect, object before change, beginning before middle, must extend infinitely in every direction, including into conditions where the very structure that makes such concepts meaningful may not yet exist. The universe does not behave like the objects we use to build our intuition about the universe.
This is not mysticism. This is the sober, mathematically grounded position of researchers working at the edge of quantum gravity, where familiar concepts like cause, before, and beginning are treated as approximations that work extraordinarily well in the universe we experience, but that may not extend all the way down to the deepest structure of reality. But to see this clearly, we have to descend one level further, because there is a version of this problem that appears at an even larger scale, and it is the version that connects everything we have discussed back to the shape of reality as a whole. If eternal inflation is correct, and our universe is only one bubble among an unbounded number of others endlessly forming within a larger inflating structure, then the very notion of a single before becomes almost meaningless. There would not be one timeline stretching back to one origin. There would be a branching, sprawling structure of countless origins, each one a local beginning within something that, from a large enough vantage point, might have no beginning at all. In such a picture, asking what came before the beginning of time is a little like asking what is west of the entire surface of the Earth.
The question assumes a single global direction that may only ever have applied locally within our own particular region of a much vaster structure. Part 6. So where does this leave the original question? What existed before the beginning of time? The honest answer, the answer that respects both the mystery and the rigor of the physics involved, is that we do not fully know. And we are not currently certain the question is even well posed in the form we are used to asking it. It might be that nothing existed before, not because there was an empty void, but because before, as a concept, simply had not yet come into being.
It might be that an earlier contracting universe existed, and our Big Bang was really a bounce, a turning point rather than an origin. It might be that we are one bubble among countless others, popping into existence within an eternally inflating structure that itself has no beginning at all. Each of these possibilities remains open, actively studied, and completely unresolved. What we can say with confidence is this: the question you asked as a child, half joking, about what came before everything, was not a naive question. It was and remains one of the most sophisticated questions a mind can ask, precisely because answering it honestly requires taking apart concepts you have never had reason to question before: time, before, cause, beginning, and discovering that each of them is far more fragile, far more dependent on ordinary conditions than you ever suspected.
Think back to the candle in the dark room, the image we began with. We ask you to notice that lighting a candle is an event that happens inside a room that was already there. And we ask you to hold on to the possibility that the Big Bang might not work that way at all. That it might be closer to the room itself coming into being, rather than a flame appearing inside one. By now, That distinction should feel less like a clever reframing and more like an honest description of where the evidence and the mathematics actually point. The room may not have been waiting in the dark. The darkness itself, and the waiting, and the very possibility of a before in which to wait, may all be things that came into existence together, if they came into existence in the way we imagine at all. You began this thinking about the beginning of the universe. But somewhere along the way, the question quietly became something else. It became a question about what a beginning is, and whether that concept can survive being pushed all the way back to the true edge of everything. The universe may have had no before, or it may have had an entire history stretching backward that we are simply unable to see. Both possibilities are, right now, equally alive within serious physics. And perhaps that is the most honest place a documentary about the beginning of time can leave you. Not with an answer, but with a question that has grown larger, stranger, and more precise than the one you started with. Still unresolved, still waiting, somewhere past the edge of everything we can currently measure.